We will do the irodov problem 257. There is a spool on which there is a force F and it makes an angle alpha with the horizontal. It acts at a radius r and the full radius of the spool is capital R. Now we have to see whether this is the direction of friction or this is the direction of friction. Direction of friction will be opposing the force. If we are applying this force, then if we are applying this force, then it will be opposing this motion. And let us look at this problem in a more close manner. Now, since there is no slipping here, no slipping, so and this force is applying some torque. There are other forces also, we'll come to that. So rotation will be in this direction and the movement will be in this direction. So to have the movement is in this direction, the friction force has to be in this direction, and this force projection in along axis F cos alpha, there has to be friction force in this direction, and F has to be greater than F cos alpha to make it move in this direction, because we are given it is rolling without slipping. We cannot have friction force in this direction, because in that case we will not get the condition given as rolling without slipping. So friction force is in this direction. So now let us write what is the total torque. This is torque due to force F. There is another torque due to friction, and which is in opposite direction to the force F, and it is Fr. And this total torque will be I times alpha. Alpha is the angular acceleration. And since it's a case of a pure rolling, in any pure rolling case, if this is the center of mass, the acceleration of center of mass would be equal to alpha times r. R is this point of contact. And angular acceleration is alpha, like this. For center of mass acceleration, it will always be alpha times r when there is pure rolling. It is only for pure rolling in such cases. So now let us write the translational motion. In translational motion, we are taking motion in this direction. What are the forces in this direction? One force is F in this direction, and another is minus F cos alpha, which is opposing it. So another point to remember is that for translational motion, wherever the force is acting, force may be acting here or here or here or here, we have to take all the forces as if they are acting at the center of mass. The forces are acting at the center of mass, so don't get disturbed by their distance from the center of mass. This is material only when torque is taken. So this is the net force, which is equal to mass into acceleration of center of mass. So now bring the two equations together. We have Fr minus Fr is equal to I into alpha is the acceleration. Don't get confused with this alpha. This is angle. This is the angular acceleration. This. And another equation is F minus F cos alpha. Don't get confused with this angle alpha and this. This is angle. Or to be safe, let me write beta here in place of alpha. Beta with the angular acceleration, so that there is no confusion. And this is equal to F minus F cos alpha is equal to m a of center of mass. Now further refine these equations. Fr minus F, this is friction force, is equal to I times beta, and multiply this second equation by capital R, you get Fr minus Fr cos alpha is equal to m capital R. What is acceleration of center of mass? Is beta times R. We have written here this beta is actually angular acceleration in place of alpha we are taking. Now add these two equations, we get Fr minus, this is sorry capital R, F capital R cos alpha is equal to mr square beta plus beta gamma mr square is given, I is given as gamma mr square. So it becomes mr square beta to 1 plus gamma, and this is f, you take common, r minus r cos alpha. So value of beta, we can get beta, which is the angular acceleration, is f times r minus r cos alpha upon mr square beta mr square into 1 plus gamma. And what is the center of mass acceleration? Is f r minus r cos alpha. We are multiplying it by r to get center of mass acceleration, mr 1 plus gamma. And we have to find this projection along the x-axis, since we had taken this positive in this direction. So along the positive x, the center of the acceleration projection would be just the negative of this, f r minus r cos alpha upon mr 1 plus gamma. This is along positive x-axis, and this was along negative x-axis, what we had taken. So this is one answer. And what is the velocity in time t? Velocity which will become in time t. Now velocity is equal to acceleration center of mass into time, velocity of center of mass. So velocity of center of mass is equal to acceleration of center of mass is given f r minus r cos alpha upon mr 1 plus gamma. We are taking velocity positive in this direction into time t. And what will be omega? Omega, because of pure rolling, omega will be v upon r, so it is fr minus r cos alpha into t upon mr square 1 plus gamma. What is the total energy of the system? Total energy will be rotational kinetic energy and translation kinetic energy, that is half I omega square plus half mv square. Just place the values, 1 upon 2 we take common, I is gamma mr square into omega square, we can write, plus mv is r omega square, or r omega we can write, anyway we can write like this, 1 upon 2 m v square gamma plus 1 is the total energy, and put the value of v is 1 upon 2 m was this, 1 plus gamma we write here, and v was v square is f square, r minus r cos alpha whole square t square upon m square r square 1 plus gamma whole square, and this becomes 1 upon 2 m 1 plus gamma, and we divide by r square here, it becomes r upon r minus cos alpha whole square into t square. F square is also there, so this is the total energy of the system which is actually work done.